So take a look in your notes, number 4. This one, of course, could be, this one could be done in a couple of ways. Hey, I'll tell you what, will you guys help me with this? I know that there's one left in 4.3 we haven't done. When we have maybe like, I don't know, 5-6 minutes left, if I haven't remembered this, will you guys remind me to go back to that one? I kind of wanted to like weave that one in at some point. So I know we've got that, but I wanted to do this here while we have some momentum going this direction. So number 4, integral from 2 to 4 of x cubed minus 2x squared plus 5. What I thought we'd do with this one is give you a chance to practice it. You watched the video, you just did the video quiz. I just showed you how to do this one. I'd like to give you a chance to do it on your own as soon as possible. I think you probably can do this just fine. We'll sum it up here in a few minutes and take questions as needed. So work together. See if you can do number 4. So here, happy to answer questions as we go. Let's see here. Our first step when trying to evaluate a definite integral is to find the antiderivative. Lainey, what did you happen to have for an antiderivative on this one?
1/4 x to the 4th minus 2/3 x cubed plus 5x.
Okay, so you guys in agreement with Lainey on that? I hope so. It's really well done. All right, great job. So finding the antiderivative first. Once you've found the antiderivative, now we need to evaluate it from those limits of integration from 2 to 4. So Lauren, I want to ask you, do I plug in the 4 first, or do I plug in the 2 first, or do I kind of have a choice? Yeah, the number, and it's really tempting to always think of it as being like the numerically higher number, but really we want to plug in the number that's physically higher, the one that's on the top. Often that'll be the numerically higher number, but whatever's on the top, we plug that in first. And you're right, that's how we do this with fundamental theorem. We accumulate from left to right there. So that's what we do. So we plug in the 4, and we plug in the 2, and we subtract. So it would look like this: 1/4 times 4 to the 4th minus 2/3 times 4 cubed plus 5 times 4. That's plugging in the 4, of course, and then we will also plug in the 2. So minus, here's where you can get into trouble. Catherine's question about parentheses was good. You can get in a lot of trouble if you don't put parentheses here, because we're going to be subtracting multiple terms. So please do be very careful with your parentheses. So it'd be minus, it'd be 1/4 of 2 to the 4th minus 2/3 times 2 cubed plus 5 times 2. Okay, so say this were, kind of that 5-point question type thing. A couple of points for the antiderivative, a couple of points that you've shown FTC1. And then if you got to do this on paper, there's still plenty of work to be done arithmetic-wise, but it is just arithmetic, so this last point would be worth probably the least, right, getting to a final answer. So I don't know what you guys came up with. I'll just do a quick simplify here. So 64 minus 128 thirds plus 20 minus, and let's see here, this would be 4 minus 16 thirds plus 10. Goodness, let's see here. What do you got?
Can you just use Math 9?
Well, so you want to be super careful with that, right? So Math 9 is not something you would use at this stage.
Right.
Right? So if calculator's active, and please know this, like on a quiz or a test, like off in the future, if I was going to have you do number 4, there is not a prayer that the calculator will be active. If I want to see that you know how to do fundamental theorem of calculus part 1, you won't even have the calculator to check. Okay, I want to make sure that you know what you're doing and can execute it all the way through. So, Catherine, to your point, if the calculator was active, I would not be doing any of these steps at all. I would just go Math 9, game over. So does that make sense?
Yeah.
Now, could you use a calculator to simplify this a little bit? Sure. I was going to do it without. So I was going to say, let's see here, 84, 80, 70. So let's see here, plus, so that'd be 112 thirds, 210. I got 322 thirds, but I'm doing that in my head.
98 thirds.
Oh, I must have lost a minus sign in there somewhere. Let me try again. So 84 minus 4 is 80, 70. Oh, Oh, I know what it is. This should be a minus sign. I did lose a minus sign. So 210 minus 112 is 98. So I agree, 98 thirds? Yeah? Okay, so 98 thirds for this one. I would say you guys, of all the classes that I've met over the years, you guys have heard about Math 9 way sooner. Did you guys pick that up in Calc or Physics C or something?
No.
Where have you heard about Math 9?
I found it.
You found it. It's fine. Hey, I got no problem with that. Just please know this. I hope that you actually hear me here. You have to know how to do this. Please don't be like, yeah, I'll just use Math 9. No, you won't, because if you do, that means you're using a calculator on the no calculator section and you fail the quiz, right? You've got a problem with that. Hopefully you do. You have to know how to do this, okay? So when you're doing your homework, please don't be like, yeah, I just did Math 9 and it all worked out great. It will all work out great in your homework, maybe, unless you have to give an exact answer, but not here. Okay, take a look at number 5, please. Number 5 is similar again. What we just did. So I don't know. Let's see here. Let's do number 5. Let's make sure that we're all clear on this. I do still see. I definitely on occasion will see people making mistakes with this. We definitely want to simplify this. Can you guys tell me how that 5 over root x really ought to be simplified before we start doing this? Yeah, Matt.
5x to the negative 1.
Yeah, that's exactly right, Matt. So what people will do here is they will make mistakes. Guys, here's the mistakes that I see. I'll see this, where you just leave it as positive 1/2. I've seen people do this, where it's 5x to the negative 1. Again, that's not right either. You are flipping up and converting over to a rational exponent, so it's got to be this. So 5x to the negative 1/2. So I'll let you guys run with number 5 for now.
Would you recommend putting 5 in front?
You can. I don't know that in this one it's going to make a really big difference, but I'd say go with what you're comfortable with on this one. One or the other, it's going to be in there, either at the start or at the end, or all the way through. So I'll leave it up to you. Yeah, Johnny.
Why is there no plus C in these type of variables?
Why is there no plus? Good. Number 5, first step is to do an antiderivative. Riley, if you're going to do an antiderivative, what did you get for that?
I got 5 times x to the, or, oh, you mean like simplify it?
I don't care. Whatever you think.
Simplify was 10x to the 1/2.
So guys, take a minute and look carefully at your number 5. Did you have 10x to the 1/2 as your antiderivative of the integrand? Okay, awesome. So now we need to evaluate from 1 to 9. So I'm going to plug in that 9 and plug in the 1. So it's going to be 10 times 9 to the 1/2 minus 10 times 1 to the 1/2. And Bianca, when you did all that, what'd you come up with? 20, I believe, is right. 30 minus 10 is 20. All right, so number 5, again, looking at that, you want to have your antiderivative represented. You want to have FTC1 represented, and then hopefully a correct answer as well, as far as points and credit, all that goes. Make sense? All right, keep rolling. I can see you guys are working on 6 and 7. 6, have you flipped up? Let's make sure we're in good shape on number 6. Remember, this is a really key point that a lot of people will forget. If you're doing the antiderivative of a fraction, you don't want to be doing that unless you actually know the form of what you're doing. And so at this point, we haven't talked about really any of those. So we want to flip up. So I would rewrite this as integral from 1 to 2 of x to the negative 2 minus x to the negative 3 dx. If you didn't do that at the start, you definitely want to do that now. It's a long line of fractions, isn't it? Okay, I'm just peeking over shoulders, looking at number 6. I feel like you guys are all kind of in the final stages of number 6 as far as I can tell. Noah's on to number 7 maybe, or is that number 6 continued? No, it's 7.
I just skipped to 7.
You didn't do number 6 at all? What's wrong with 6?
I had started on 7.
Okay.
I had to finish it.
So, oops, sorry. So just an accident.
Yeah.
Oh, no problem. No problem. Matt, how you doing? Doing all right. Yeah, it's hard to do. It's hard to do this without a calculator. Do you have any questions?
Because like I think I got the antiderivative,
Yeah, that's a good start. Yep.
and then like I tried inputting. Wow. I don't think I did it
Okay.
right.
What'd you get, man?
1.52661801.
Hey guys, let's take a look at number 6. So maybe you've moved on to number 7, and if you have, that's fine. But let's go back to number 6 and make sure that you're doing okay. First step is to find the antiderivative. This is really a huge key, so take your time and do your best to do it right. Zach, what did you get for the antiderivative on number 6?
1/2x plus 1/3x squared.
Let's see here. So you simplified it. I gotta think this through. So what I would get here is that I think we differ. So I'm a little bugged by your 3. I feel like you didn't add 1 to your exponent on either case. Am I?
Up and took the number down first, then
I think that's what it is. Yeah. So let's rethink that. So, hey guys, let's focus on 6. I want to make sure you're good on this. So Zach, my thought was this. I always add 1 first. And so I'm going to write down x to the negative 1. And then I'm going to divide by that new exponent. So it's dividing by negative 1. All that really does is it changes this to be a negative. Does that make sense? So then on the next one, again, I'm just going to add 1 to that exponent. So it's going to be x to the negative 2. And then I know I'm going to divide by negative 2, but I already know that that term is negative, and a negative over a negative is a positive. So I'd maybe put plus 1/2 x to the negative 2. Does that go okay? Or how do the rest of you guys feel about that? Does that work with what you have? There's obviously some slightly different forms, but any questions? All right, fair enough. So we're going to evaluate this from 1 to 2. So let's see here. This would be negative 2 to the negative 1 plus 1/2 times 2 to the negative 2 minus the negative of 1 to the negative 1 plus 1/2 of 1 to the negative 2. All right, so where does this go? Coming back up here, I would say this is negative 1/2 plus 1/8. I'm getting that from this and this minus negative 1 plus 1/2. So it would be negative 1/2 plus 1/8 minus negative 1/2. So I'd say that this would add out with this. I think we'd end up with a final answer of 1/8. What do you guys think? Any questions?
What happened to the 1? The negative 1?
So negative 1 plus 1/2 is negative 1/2, which I put right there. So again, I want to be I want to be ultra clear on this. I want you to hear what's valued. On a quiz or a test, I think I'm going to ask you at least one question where you're going to have to go through some kind of a process like this. I'm going to put a premium of points on your antiderivative. That shows you know how to do an antiderivative. I'm also going to put a premium on points of you doing FTC1. I will put a minimum of points premium on the arithmetic that might follow. Okay? So it's possible you might have looked at this and be like, man, I did not get 1/8. I got something crazy different from that. You would definitely get, say, 4 out of 5, 3 out of 4, however the points worked out. That all that arithmetic stuff at the end would only be worth at most a point. Just so you know. Okay, please try number 7 if you have not already started.
I did that before, and then I go.
So number 7. Hey guys, listen up, please. One of two ways you could know how to do number 7 as far as an antiderivative. Either you've memorized all the antiderivative rules, maybe, or perhaps you remember that the derivative of something is that integrand. The derivative of what is that integrand? Cosecant, right? Yeah. So one of the two ways at least you got to be able to handle that. So we would say the antiderivative is cosecant of x evaluated from pi over 4 to 3 pi over 4. And here is where your old friend, the unit circle, would make his or her appearance. Fundamental theorem of calculus part 1 would look like this. So I would say this, if you're taking a quiz or a test and you got to this point, you got your antiderivative, you've got your fundamental theorem of calculus part 1 illustrated, you have earned all but 1 point, right? At most, you'd have to evaluate this. You'd earn at most 1 point for that evaluation. So let's see here. Cosecant of 3 pi over 4 would have to be 3 pi over 4. Let's see here. No, it would be root 2. I was thinking of the positive negative. We're in the second quadrant there. So root 2 minus cosecant of pi over 4 in the first quadrant, definitely root 2. End up with 0. Interesting.
Math 9 is always super exact.
They give you like a scientific notation. Yeah.
The negative 15 power.
Sure. So guys, listen up, please. Listen up. Hush. What does this mean about the graph of negative cosecant x cotangent x on the interval from pi over 4 to 3 pi over 4? In regard to area, since the integral gave us a 0, the area
Equaled out.
equaled out, positives and negatives, and so half of the graph would be where?
Below the x-axis.
Below the x-axis, and the other half would have to be above, wouldn't it? And that is the period. It's full pi, right? 1 pi period. No, actually, no, it's 2 pi period. This is just, actually, I think what this is half of the positive part and half of the negative part. Because you know, it's just the series of like parabola-ish looking loops. So I think I got half of one and half the other on this one. So, all right, I thought we'd do this last one together and look at this. Look at this graphically. I think this will probably be our last one to do for today. This is a great place to finish. Okay, so if g of x is equal to that piecewise, we'll go back and do 4.3, the last little example there. So if g of x is equal to that right there, evaluate the integral from 0 to 2 of g of x. So you notice, of course, that the split in the piecewise is right in between my limits of integration, right? It's not in the middle, but it's in between, right? 0 to 2, the 1/2 is in there. And so we're going to have to consider how this is all going to work out. I thought maybe we could do a little bit of graphing, and so I will do that here as well. So here is a y-axis and an x-axis over there. So from 0 to 1/2, it's sine of pi x. So let's think about what that would look like. From 0 to 1/2, sine of pi x. Well, it's sine, right? And so where does sine start? Does it start high, middle, or low? Starts high. So it's going to be sine and let's see here. Sine of, so it's going to be did you guys say it starts high or middle or low? It should start middle. I feel like I just said high, but it should start middle. Cosine starts high, sine starts middle.
Yeah.
So it's going to go... Sorry, I'm trying to get this curve good. So sine of pi over 2 is 1. So I would say the sine part is right there. But once you get to 1/2, no longer is it the sine part. Now it is a line. And the line, let's see here. The line is going to do, let's see here. Line's going to do something like this, right? Okay, so we're supposed to evaluate from 0 to 2. And so essentially I've got this area between the x-axis and the sine curve. And then I've got this other area stuff going on with the line. So when you think about trying to evaluate this, what strategy do you think we're going to have to do? We're going to have to split them up, right? Because we got two totally different functions here. We got intervals going on. We're going to need to split this up. So we could split it up like this. We could say integral from 0 to 2 of g of x, and we're using one of those properties we talked about at the end last time, equals the integral from 0 to 1/2 of g of x plus the integral from 1/2 to 2 of g of x. We're splitting it up right there on the piecewise part. It's where the functions switch to a different function. And then from this point, what we need to do is plug in the pieces that go in the appropriate spots. So I would say this equals the integral from 0 to 1/2. And then g of x for that particular domain would be our sine of pi x. dx, and then integral from 1/2 to 2. And that would be of our line, negative 4x plus 6 dx. I'll just take a moment here to pause and just ask you, does this make sense to you from a properties perspective, and like which function went into which integrand going with the particular domain? Do you have any questions about that setup? We're going to take a little bit of a radical departure from how we're going to figure this out here in a second. Any questions at all? Please don't try to finish this by hand yet. Okay? What you're going to find, yeah, hands off, right? What you're going to find is that the second integral is actually going to be pretty straightforward and easy for you. We have not yet learned how to do the first integral. And so I thought this would be a good opportunity for us to use Math 9. For those that have not discovered this yet, in certain situations, this will be extremely helpful and borderline mandatory. So this is a great skill for you. So what I'm going to do is flip screens on you and show you how you could use Math 9 to do this. So check this out. So in your calculator, what you want to do is just start off by pushing Math 9. And if you've got that newer operating system, you get something like this. It's a thing of beauty. Did anybody see like FN int? So when you push Math 9, everybody got that? Awesome. So this looks like what we're trying to do, doesn't it? So what I would do is I would fill in exactly what needs to go where. So I would say integral from 0 to 0.5. My integrand is sine of pi x dx, and that's my first one. I'm going to add to that another Math 9. So I'm just going to basically type it out the way that I write it. So this integral is going to go from 0.5 to 2. And this one was negative 4x plus 6. Am I remembering right? Yeah. Okay. So negative 4x plus 6 dx. So I want to say that that integral that we set up, integral expression we set up a minute ago, by the time we're done with chapter 4 in January, you will definitely know how to do that without a calculator. But in the near future, you doing this Math 9 thing will be very, very helpful, and we will use it. So just be balanced about it. Don't be like, I'll never use Math 9, or that's all I'll use. Realize, bless you, some situations Math 9 is the thing to use. In other situations, it's not. So know how to do both ways. Obviously, at this point, you just hit enter, and it gives you this wonderful answer of 1.818 approximately, and that's it. You're done. So do you see how Math 9 is similar to Math 8 in its usefulness? It'll do a lot of awesome stuff for you, especially when you have this newer operating system. Okay, so guys, I do want to go back and I want to catch that last example in 4.3 and just kind of see where we stand at that point. So let's go back a little bit to 4.3, which is right here. Correct me if I'm wrong, we did number 9 last time, right?
Yes.
But not number 10.
Yes, sir.
So please try number 10. This should finish us up here just about right at the end of our class. So guys, for number 10, did you guys see a couple things here? For instance, did you see how the 3 and the 4 can and maybe should come out? So maybe you'd write this as -3 integral from -2 to 5. Hey guys that are talking, just quiet down please. We're almost done. Plus 4 integral from 3 to 7 of g of x dx. Use that property there. And then I suppose, really that first one, we can just directly go. We can see that the integral from -2 to 5 is 4, right? So this would be -3 times 4 plus 4 times, and the integral from 3 to 7 is 10, so 4 times 10. Making sense? So I'd go -12 plus 40. I'm coming up with 28. That work for you? Did anybody have any questions on number 9, the one that was previous to this? Because I know we did it right at the end last time. I don't remember what the answer is. Let me do it real quick. So, oh, that's right. It is. Yeah, -26. So, that sounds right. I remember something about that. I don't know if anybody had any questions on that, or maybe you all did have -26. If so, that's great. We good? Okay, let me do 2 things here. We got about 5 minutes left. I wanted to kind of